Solve problems on queuing model 7, which is multiphase service model, by using important formulae.
Let us understand some important formulas related to queuing model 7. It is also known as multiphase service model. It is symbolically represented as MEK1 FCFS infinity. In this model, Poisson arrival distribution is there and symbol is M. Then it is Erlang service time distribution with K phases, symbol is EK. Number of servers provided, that is 1. Service discipline is on the FCFS, that is first come first served basis. Number of customers allowed in the system, infinity, and calling source or population, that is infinity. Let us understand the characteristics of this queuing model 7. Here Erlang service time distribution is with K phases. Now we will understand the meaning of K phases with the help of diagram. Now if we observe this system, here are the units. We will consider here M number of units, and there are total number of service facilities are 4, and these facilities are arranged in series. So here is service facility 1, service facility 2, service facility 3 and service facility 4. So here number of service facilities are there, that means this is Erlang service time distribution with 4 phases, that is K is equal to 4, and these facilities are arranged in series. Suppose at any time there are M units waiting in queue with 1 unit in service which has still passed through S phases. Now we will understand this statement with the help of this diagram. So there are M units waiting in queue. So this is the queue and these are the M number of units. Now there are total number of service facilities 4, that is K is equal to 4, and 1 unit is taking service. So here 1 unit is taking service with SF1 and it has to pass through S phases, that is remaining phases, that is equal to S. So S is equal to 3. So how to calculate the total number of phases in the system at that time? So total number of phases, that means we have to calculate. So we will consider this total number of phases N. N is equal to this M multiplied by K plus S, because here only 1 unit has to pass through this S number of phases. So we have to add plus S. Now we will move to the formulas which are useful to solve the problems. First formula, average number of units in the system, that is the length of the system. Ls is equal to K plus 1 divided by 2K lambda by mu, lambda divided by mu minus lambda plus lambda by mu. Second, number of units waiting in queue, that is length of the queue. LQ is equal to K plus 1 divided by 2K lambda by mu into lambda divided by mu minus lambda. If we compare these two formulas, then for the length of the system we have to just add lambda by mu. Third, average time spent by unit in the system, that is time in the system, that is WS, which is equal to K plus 1 divided by 2K into lambda divided by mu into mu minus lambda plus 1 by mu. Average time spent by unit in queue, so waiting time in queue, that is WQ, which is equal to K plus 1 divided by 2K into lambda divided by mu minus lambda. If we compare these two formulas, that is WS and WQ, then in WS we have to just add this 1 by mu.
First question. In a factory cafeteria, the customers have to pass through 3 counters. The customers buy coupons at the first counter, select and collect the snacks at the second counter, and collect tea at the third. The server at each counter takes on an average 1.5 minutes, although the distribution of service time is approximately exponential. If the arrival of customer to the cafeteria is approximately Poisson at an average rate of 6 per hour, calculate first the average time a customer spends waiting in cafeteria. Second, the average time of getting the service.
Let us understand the given data with the help of diagram. It is given that the first service facility is for coupons, second for snack and third for tea. So there are total 3 number of service facilities which are arranged in series. So here we can say that K is equal to 3. Then the service time per phase is also mentioned 1.5 minutes. That is for each and every service facility it takes 1.5 minutes. Now we will calculate what is the service time per customer, because each and every customer has to pass through these 3 phases and it takes the time for 1.5 minutes for each facility. So a service time per customer 1.5 multiplied by 3, that is equal to 4.5 minutes. Now these minutes we will convert into hour. So in 1 hour there are total 60 minutes. So 4.5 divided by 60, that is 4.5 divided by 60 hours. Now we will calculate the service rate. So we know that service rate is equal to 1 divided by service time. And service time we have to take in hour, because arrival rate is also mentioned in hour. So we will take 1 divided by 4.5 divided by 60 customers per hour, and which is equal to 60 divided by 4.5, which is equal to 40 by 3 customer per hour. Then arrival rate lambda is mentioned in the question 6 customers per hour. Now with the help of this lambda as well as mu, we will find out the first question, that is the waiting time for each customer in the queue. So waiting time, that means that customer in queue. So we have to find out WQ. So what is the formula? K plus 1 divided by 2k lambda by mu, 1 divided by mu minus lambda. So we will put the value. So k is 3. 3 plus 1 divided by 2 into 3 into lambda by mu. That is 6 divided by 40 by 3. So this 3 in the denominator we will shift to the numerator. Then 1 divided by mu minus lambda, 1 divided by 40 by 3 minus 6. So if we solve this, we will get the answer 9 divided by 220. So if we observe mu and lambda is having unit hours, so this answer will also be in hours. Now we will convert this into minute by multiplying with 60. So which is equal to 2.45 minutes. Now we will move to the second question. Second question is average time getting the service. So if we observe, each customer has to pass through 3 phases to get the total service. So each phase requires the 1.5 minutes. So what is the average time in getting the service? That is 1.5 into 3, that is 4.5 minutes. So we can say that average time is in getting the service, that is 4.5 minutes, and we can also write this answer in hour, that is 4.5 by 60 hours.
Second question. Repairing a certain type of machine which breaks down in a given factory consists of 5 basic steps that must be performed sequentially. The time taken to perform each of 5 steps is found to have an exponential distribution with mean 5 minutes and is independent of other steps. If these machines break down in a Poisson fashion at an average rate of 2 per hour, and if there is only one repairman, what is the average idle time for which machine that has broken down? This question was asked J.N.T.U. Hyderabad B, April 2011.
Let us understand the given data. There are total 5 number of phases are given to repair the machine, and which are arranged sequentially, that is one after the other. So we can say that number of phases k is equal to 5. Then the service time per phase is also mentioned. So for this first phase it requires 5 minutes, second phase is also 5 minutes. So for per phase it is 5 minutes. Then what is the service time for this whole unit? So to repair the machine, it has to pass through this total 5 phases and it requires the total time, that is 5 minutes plus 5 minutes plus 5 minutes plus 5 minutes plus 5 minutes. So we can say that 5 multiplied by 5, that is equal to 25 minutes. But if we observe, lambda is given in hour, so we have to convert this time into hour, that is 25 by 60 hour. So this is the service time per unit. So what is the service rate? So service rate mu is equal to 1 divided by service time. So 1 divided by 25 by 60. So we can write 60 by 25 units per hour, which is equal to 12 by 5 units per hour. And arrival rate lambda 2 units per hour, that is mentioned in the question. Now what is the question? We have to find out the idle time of machine. Now if we observe here, the machines are for the repairing purpose. So for repairing purpose, these are the machines passing through these 5 phases. So whenever the machines are in system, then only machines are idle, because these machines are not working, these machines are broken down, and that's why these machines are arriving into the system. So we have to find out what is the time spent by machine in the system, that is WS, and within that time only this time is considered as the idle time of the machine, because these are involved for the repairing process. So what is the time spent by machine in the system WS? That is equal to K plus 1 divided by 2K into lambda by mu into 1 divided by mu minus lambda plus 1 by mu. So we will put the value. So K is 5. 5 plus 1 divided by 2 into 5. And here lambda is 2 divided by 12 by 5. So I will take this 5 to the numerator, into 1 divided by 12 by 5 minus 2 plus 5 by 12, that is 1 by mu, that is we have to take this 12 by 5, so 5 I will take in the numerator. So what is the answer? 5 by 3 hour, because if we observe lambda and mu, the units is hour, so we have to take here unit hour. Now we can convert this into minute, because in 1 hour there are total 60 minutes, so multiply here with 60, so which is equal to 100 minutes.